Section 8.2 is on characteristics of quadratic functions. So we're going to learn more parts of a quadratic function, parts of a parabola, and what they're called. The first one is a zero of a function. This is where a parabola crosses the x-axis. This is also known as the x-intercepts. And if we had gone further into the chapter, it's called the solutions of a quadratic function. So it's all about where it crosses the x-axis. It is also when y equals 0. So we have three scenarios. You can either have, in the first example, two zeros. In this first example, it crosses the x-axis in two places, and that's just based on its positioning on the graph. In the second example, it has 1 0, and this 1 0 is also, vocab word from last section, is the vertex. It's a coincidence that the exact point that it touches the x-axis is also the vertex. So in that circumstance, there's only 1 0. Then we have this third situation where it never crosses the x-axis. So there are no zeros. Technically, there are 0 zeros. No one's going to write that, though. The answer is not 0. It's just that the fact that they have none. You could also say none. If they were to ask you how many do they have, you can say no zeros, or you can say that they have none. So let's take a look at some examples. In the first set, directions just say find the zeros of each quadratic function from its graph. Check your answer. So in these particular questions, not only do they give you the equation, but they also give you the graph. To be honest with you, the graph is the only thing you need for right now. Again, later on in the chapter, they wouldn't be giving you the graph, they would just give you the equation. But let's make it as easy as possible, and since they're giving you the graph, focus on the graph and you're using your eyesight. So, in this first example, again, they're not asking me how many there are. They want me to specifically find the zeros. So I have to name the x-coordinates. So this is where it touches the x-axis. And the two places that it touches the x-axis are at 2 and -1. So my answer is -1 and 2. Now you can write it like this. You can write it like that. Just do not, under any circumstances, put parentheses around it, because then that's saying something totally different. It's calling it a point, and it would be wrong. So that's a big thing. If this was on quizzes and I made you do a fill in the blank and you put parentheses around it, you would get it wrong. Not only would quizzes mark you wrong, I would mark you completely wrong, because that means something else. Okay, in example number 2, this is an example where it only touches the x-axis in one place, and that coordinate is at +1. So my answer, I would just say 1. For the third example, you can clearly see that there are no zeros. So you would write no zeros. Do not write 0. If you write 0, you're saying that it crosses it right here. It does not cross or touch the x-axis at 0. So you'd be wrong if you said 0. You need to say no zeros or none, N-O-N-E. Now you can always check your answer by taking the numbers. That's what they did down here, is where they were checking the answers. Again, if you had time, if it was something really important for you to check your answers, this is what you would do. You would take the number, in this case in letter B, I would take number 1, and I would plug it back into the equation here and here, just as they did, and make sure that you get 0. Because as I stated above, this is when y equals 0. So it's important that after you plug in those values that you get 0. In the first example, in answer A, they did it with -1. They plugged -1 in here, which was this part right here, and it does equal 0. Then they did it with the number 2, and when you plug in number 2, you got 0 there, so you know you're correct. All right, let's try these examples. Again, I don't even really need to look at this, okay? I'm just going to focus. I would use those equations to check my answer. However, I'm just going to look at the graph, and in 1A, notice it does not touch the x-axis, so my answer is no zeros. In this 1B, it touches only in one place, and that one place is 3. Once again, if you quickly wanted to check your answer, Again, maybe your life depends on it and it's really important. 9 minus 18 plus 9. Negative 9 plus 9 is 0. So I'm 100% correct. Okay. Next vocab word of the day here is axis of symmetry. This is a vertical line that divides a parabola into two equal halves. This is like in kindergarten when you, or maybe in preschool, when you used to make little butterflies and you would take a piece of paper and you'd fold that piece of paper in half and then you'd cut it into the wings and then you'd open it up. That crease in the paper, that's basically an axis of symmetry. But instead of it being a butterfly, now it is a parabola. So what it would look like in a picture, and it's usually just it's invisible. It's a dotted line that comes down the middle. Very important. It goes through the vertex. Always goes through the vertex. It has to go through the vertex. And also, the axis of symmetry is a vertical line. Therefore, it is written as a line. So, for example, if it was at 3, my axis of symmetry, I would write it as x equals 3. If you write just plain old 3, you're going to get it marked wrong. So make sure you write it as an equation, which means you have an equal sign, and it's always going to be x equals 3. It's never y equals 3. Y equals 3 would be a horizontal line, and that's not what we have. You'll do that kind of fun stuff probably in college. Maybe some of you may get into calculus, and that's when you start doing horizontal lines and all kinds of fun stuff, but not for us. All right, so once again, graphs are given to me. When graphs are given to me, it makes it very easy to find the axis of symmetry. You're going to locate the vertex, which is what we did last section. So when I locate my vertex in this first graph, right here, my vertex is at 2, 0. So I'm just going to use the x value. The x value is 2. So therefore, my axis of symmetry is x equals 2. Now, it looks like in letter B that my vertex kind of looks like it would be at 3, negative 8, but I'm not 100% sure, specifically because they did not put a dot there for me. It's the first time that they did not put a dot for me, so I can't assume that it's definitely at 3, negative 8. So what I have to do is basically you're finding the middle point in between these two, okay? It's the average of those two. So this first dot on the left is at 1, the dot on the right is 5. So to find the average of those, or basically you're finding the midpoint of those two, you add them together, 1 plus 5 divided by 2, which gives me a 3. So my final answer is x equals 3. All right, 2a. This one is the easier one because they do indeed give me the vertex. And my vertex here is at negative 3, 0. So it's always going to be the x value of your vertex. So my answer is x equals negative 3. In 2b, once again, they don't give me the exact. It kind of looks like it'd be at 1, maybe 4.5. But again, I'm not going to go on eyesight. I'm not going to make any assumptions. I'm going to find the average of these 2 points. The one on the left is at negative 2. The one on the right is at 4. So I'm going to add negative 2 plus 4. Divide that by 2. 2 divided by 2 is 1. So therefore, my axis of symmetry is x equals 1. Once again, notice that how I wrote my answer. If you don't write the x equals, you will get it wrong, okay? It's a big deal for you not to have it. Just saying 1 means something totally different. So you got to have the x equals when they want the axis of symmetry. I know there's some people out there that are still going to ignore my warnings and get it wrong and then cry about it and say, well, why is 1's the same thing? No, it means something totally different. So please make sure when they ask for the axis of symmetry that you write it as x equals the number. All right. So these 4 questions that we just did is when they give you the graph. Well, they're not always going to give you a graph. So the next situation is when you are not given a graph. You are going to use this formula, x equals negative b over 2a. You get those letters, the b and the a specifically, from your standard form of your equation. A is the number that's in front of x squared. B is the number in front of X, and C we don't need. So let's take a look at this first example. Find the axis of symmetry of the graph y equals x squared plus 3x plus 4. So your A value, again, there's nothing there. That doesn't mean there's a 0. There's an invisible 1. B is 3. C is 4. So my formula is x equals negative b over 2a. So I have negative b, which is 3, over 2 times a. This gives me negative 3 over 2. So my axis of symmetry is x equals negative 3 over 2. If you want to make that negative 1/2, that's fine. That's a pretty decimal in my book. You don't want, if it was 2/3, you would keep it as 2/3 because that's 0.6 repeating, and we're not going to have any of those gross decimals. So if it's a nice decimal, it goes out 1 or 2 places, it's okay to use the decimal form. You could also say negative 1.5. That's acceptable as well. Mixed numbers don't really, they don't really play a part too much at the level that we're in with algebra. It's just not used very often. They use either the improper fraction or the decimal form. All right, let's take a look at the second one. So my A value is negative 2. My B value is 1. My C value is 3. Again, your equation is negative B over 2A. So I have x equals negative 1 over 2 times negative 2. So I have negative 1 over negative 4, which gives me 1/4. X equals positive 1/4. Once again, you can make that a decimal, and it could be 0.25. Now, one thing I want to bring to your attention, if for some reason this same problem that I just did, let's pretend it was 2x squared plus x plus 3. Same problem, the difference is my A is positive this time. Or actually, I'm sorry, let me make this one. My B, I wanted the B to be negative. It's negative x, and my C is 3. So when I go and I plug this in, x equals the opposite of B, which my B is negative 1. And then I have 2 times negative 2. Negative, negative, that becomes positive on the top, and the bottom is negative. So be careful when plugging in a negative number that if there's a double negative, that it does become positive. So in this example, x would be negative 1/4. Okay, now, next we're going to find the vertex of a parabola. Now in section 8.1, we did that. You just used your eyesight. You read a graph. You looked at the graph, and you found where the vertex was, and you identified it by naming the coordinates. Well, now we're going to do that where a graph is not given to you. So to find the vertex, you need to find, it's going to be a coordinate point, so this answer will have parentheses around it. You are going to find the x value by using the axis of symmetry, which is the formula that we just did. That's your step 1. So step 1, I'll write it in a different color. We'll say this is step 1. You're going to find the axis of symmetry. Step 2, that's going to give you your x value. So to get your y value, you are going to plug x value into the equation. This will solve for the y value, and then you have your answer. So let's do an example. We're going to find the vertex here. I'm sick of pink. Let's go turquoise. I'm in the mood. Okay. A is negative 1. B is negative 2. C, there's nothing there, so that'd be 0. So step 1, you are going to find your axis of symmetry. X equals negative B over 2A. It's going to be negative, negative 2 over 2 times negative 1. This would be 2 over negative 2, which is negative 1. Therefore, my axis of symmetry is x equals negative 1, which that means that the x part of the vertex is negative 1. Now to find the y value, step 2. I'm going to take this negative 1 and I'm going to plug it into the equation. So I have negative 1 squared minus 2 times negative 1. And now I'm going to solve. This gives me negative 1 plus 2, which would give me 1. So my answer is at negative 1, 1. Let's try another one. Okay. For this one, A is 5, B is -10, C is 3. I don't need to write 3 down. I don't need to say anything about the C because it's not used at this point in time. I'm just getting you accustomed to seeing and identifying what C is, because later on there are formulas that you need in order to use the C. So I just wanted you to get comfortable with it. So again, step 1, I'm going to find the axis of symmetry, which is the x value. So x equals -10 over 2 times A. This gives me 10 over 10, which is 1. Now, the only thing that a calculator is going to do for you is just help you with that basic math. There's not much else that I can do with the calculator at this point, other than if for some reason you didn't know what 2 times 5 was. Now I'm going to plug it into the equation for x, since I know what x is, and I need to figure out what y is. This is 1 squared is 1 times 5 minus 10 plus 3. -5 plus 3 gives me -2. So my vertex is at 1, -2. Okay, one more here. We've got A is 1, B is -4, C is -10. Again, step 1, find the axis of symmetry. So -4 over 2 times A. This also gives you practice finding the axis of symmetry. If the directions asked you for the axis of symmetry, then you would be done at this step. However, my directions to these particular problems wanted the vertex. So be careful that you know the difference between the directions. 2 squared minus 4 times 2 minus 10. 4 minus 8 minus 10. This is -4 minus 10, which gives me -14. So my vertex to number 3 is at 2, -14. Now, last but not least, our favorite thing, word problems are finally back. We've taken a break from word problems for, I don't know, probably like 2 months. We haven't had a word problem since chapter 5. We didn't have any in 6 or in chapter 7. So they do make somewhat of a comeback. Again, we're only doing the first 3 sections. So there's really only word problems in this section and in section 8.3. And that's it for word problems for the school year. Now, this particular problem gives me an equation for this parabola right here, for the parabola that makes up this bridge. And if you can see in the background right there, there's a sailboat. And the sailboat is trying to figure out if they want to know, can the sailboat that is 24 feet tall pass under the bridge? So they want to know this height right here is basically what they're looking for. They need to know that maximum height in order to figure out if that sailboat can come through. So right here, what you need to recognize, again, they don't use any words that would signal what they're looking for. They don't say maximum. They don't say vertex. They don't say axis of symmetry. They don't say anything that would tell you algebraically what they're looking for. So it's your job to figure out, well, what is it that they're actually asking for? And in this particular problem, since they want to know this height right here, this point right here is the vertex, which your x value is your axis of symmetry. And from last section, the y value is either going to be your maximum or your minimum. In this particular problem, it is the maximum because it's the highest point. That's the value I want to know. I want to figure out what that maximum is. If this boat is 24 feet, I need that maximum to be more than 24 feet, okay? Otherwise, this boat, its head will get chopped off and it will not fit under the bridge. So I want to get it as much higher than 24 to have a safe passage underneath the bridge. So in order to do that, that's exactly what I did up here, is I found the vertex, but I needed to focus in on that y value. So they do this for me. So we'll do our number 5 on our own, but since they do all the work for me, they also gave me the equation, thank God. Towards the end of the chapter, you have to come up with some equations on your own. We're not getting that far, so we're going to take advantage of the fact that the equation was given to me. I'm going to plug in my b value and my a value into negative b over 2a. That gives you 60 for the vertex, for the x value. Then 60 gets plugged in and you get 26. So my y value is 26. So to answer their question, yes, the sailboat can pass under the bridge because the bridge height is 26. They say it a little bit, they say it another way right here, but it's pretty much the exact same thing. So basically, yes, it can make it under the bridge safely. Let's look at this second one. All right, I've got my equation right here. Here they're talking about a roller coaster and the height of a small rise. Okay, so a rise would go up, come down, whatever's going on. They need to know what the height or the support, does this one have a support? Yes, a support pole that holds up that rise of the roller coaster. Once again, in order to find out the height, I'm going to find the vertex and I want the y value. Everything is determined by that y value. So first step, I'm going to find my vertex, negative b over 2a. My b value here is 0.42. My a value is negative 0.07. This I am going to have to, what do I have? Negative 0.42 over negative 0.14. This gives me positive 3. So 3 is the x value, but remember, it's the y value that tells me the height. So now I'm going to take 3 and I'm going to plug it back into this equation. 3 squared, and this comes out to actually, surprisingly, with all the crazy decimals it has, when I type that in my calculator, I get 7. So they want to know, find the greatest height of the rise, and the answer is 7 feet. I don't even care if you put the feet, you can just put 7. Okay, so what I want you to work on right now, you're going to go to page 535 and 536, and you're going to complete 3 through 18 all before returning to Zoom and being prepared to answer any questions that I might have. I think there's one question, number 12. It comes out to a not so pretty decimal, so keep it as a fraction. Everything else is fine. They come out to be normal numbers for you to be able to do. So just number 12, it's just keep it as a fraction. And then the other ones are pretty fractions and pretty decimals. So whatever you need to do. So I'll see you in a little bit in Zoom.